In this video, we're going to build the prefab object that we will use for the player in this project. Let's start by creating a new folder in our assets where we can store prefabs. To begin the prefab, let's take the image from the idle animation and drag it into our scene. This will attach the image to a game object in the scene. The first thing we'll do is rename the object to player. Now we'll begin adding some of the standard components that will be required for the player object to collide with the objects in the scene. First, we'll attach a box collider 2D. Second, we'll attach a rigid body 2D. We are going to adjust some of the options for the rigid body so the physics works better with our controller. We want to set the collision detection to continuous to ensure that the player can't easily go through walls if they are moving at a high speed. Next, we'll set the interpolate option to interpolate. This will make sure that the player moves smoothly between each physics time step. Now, let's edit the collider so that it fits nicely around the shape of the player. We don't want the collider to go right up to the edge of the player's sprite because the continuous collision detection has a little buffer around the edges to help ensure that the collider doesn't move through walls. If we look at the feet where the player will stand on the ground, we can get a good idea of how large the spacing needs to be. This option can be adjusted in the Physics 2D settings if you would like to test out different offsets. It is called Default Contact Offset. Now, we'll make sure that this offset is roughly the same around the entire player's sprite. Finally, let's add an animator component to the player prefab so that we can begin to set up the player animations. We will also need to create an animation controller for this animator component to use. Let's start by creating a new folder where we can store all of our animation assets. The first thing we'll add to this folder is the animation controller that we need for our player's animator component. We'll name this controller Player. Now we can select this controller using the controller field on our animator component. Once we have the controller selected, let's open the animation window and the animator window so that we can begin building the player's animations. I usually like to dock these windows alongside the main scene view window in the center. Before moving on, let's take what we've built so far and transform the game object into a prefab that we can store in our prefabs folder. We can do this by simply dragging the object into the prefabs folder. You can see that the object in the scene is now highlighted in blue. This lets us know that it's an instance of a prefab. Now we can delete the object from our scene and we can begin editing the prefab directly. To do this, we can select the prefab that we just created and then click on the Open button that is at the top right of the inspector view. This will bring us into a special scene that consists only of our prefab. If we edit the prefab here, then our changes can be applied to every instance of the prefab. Now we are ready to begin creating all of the animation clips that our player will use. Let's bring the animation window to the front and then click the Create button to generate our first animation clip. We want to store this clip in the animation folder we created a moment ago. We will start with the player idle animation. The format of these clip names will be used in our script, so make sure that you type them exactly. Let's lower the frame rate for our new animation. This option is listed under Samples right next to the name of our new clip. We'll change the rate to 10 frames per second. Now we can look into the Images folder we copied earlier to access the textures we are going to use to build each clip. Find the Player Idle folder, and then we can drag the texture directly onto the animation clip timeline. In this case, the animation is only 1 frame long for simplicity, but some of our animations will have multiple frames. We can clear this warning because it was only letting us know that our animation controller was empty and we just fixed that. We can now follow the same process with all of the other animations that we will need for the player. Each animation clip has its own folder that is named with the appropriate animation clip name. If we click on the drop-down where it says Player Idle, there is an option to create a new clip. This will set us up with an empty animation clip for the next set of textures. Make sure that you carefully type the name of each animation clip and make sure to set the samples for each clip to 10. Then, drag all of the textures that are in each folder onto the animation clip timeline to finish setting up the clip. Now we can repeat this process for each of the player's animations. If we look at the animator window when we're done, we can see all of the animations we have just created for the player's controller. There's one last thing we are going to do to set up our animations. The climb ledge animation will never be played in a loop. We will only run the animation once each time the player climbs a ledge. So let's turn off the loop time option for this animation. This will ensure that the animation doesn't start running again if there is a small delay before the player is put into the next animation state. That completes all of the setup we need for our player prefab and its animations. We're now going to begin setting up the tile maps we will use to build a level for our player to run around in. Let's start by adding a global light to our scene, because without it we won't be able to see any of the objects. The 2D light options will only be available if you have the Universal Render Pipeline package installed and set up correctly. So if you're still missing these options, refer back to episode 1 where we set this up. We're going to use a global light, which is a light that simply fills the entire scene with a constant light value. I'm also going to reset the position of the light so that it sits at the origin of our scene. Now, let's open the tile palette window so that we can begin setting up the tile assets that we will need for the tile maps. I like to dock this window next to the project console window in the lower right. We will create a new tile palette using the drop-down in the tile palette window. We'll call this World Palette and keep all of the default options. Let's make a new folder in Resources where we can store the tile palette and the tile assets we're about to create. We'll call this folder Tiles. Now that we have an empty tile palette, we can locate the tile sprites we imported in episode 1 and then drag them onto the palette to automatically create the tile assets associated with each sprite. Let's save these tile assets into the Tiles folder we just created. We can now see each tile displayed in our tile palette. Let's rename each of the tile assets so that we can more easily access them in our scripts. Just like the player animations, you will want to be careful about these names because they will need to match exactly with what we write in our scripts. Now we'll begin adding the tile maps to our scene. We are going to use 3 different rectangular tile maps to represent the different layers of our stage. When we add our first tile map to the scene, it will automatically include a grid object as the parent. This object serves as the foundation for tile maps. We will name our first tile map Structure, and this is where we will put all of the solid tiles that the player can collide with like a wall. Let's start by creating a line of solid tiles that our player can stand on like a floor. If we select the block metal tile from our tile palette and choose the paintbrush tool, then we can begin painting these tiles into our scene. Now, let's add another tile map to represent all of the objects that can be climbed in our stage. We will call this tile map Climbable. Let's also move this layer above the structure layer in the scene hierarchy, and then we can set its order in layer field to 1. Our structure tile map is set to the default value of 0, so this will place our climbable layer above the structure layer in the scene. Now we'll add the last tile map layer we need for our stage. This layer will be called Overlay, and it will represent items we want to place above the other layers like a boundary that lets the player know where the stage ends. We will move this layer above the other 2 layers in the scene hierarchy. Let's also open up our player prefab so that we can place the player above all of the tile map layers. We will assign the prefab an order in layer value of 3. And then we can assign the overlay tile map a value of 2. This will put all of our tile maps at their own value below the player. The overlay is at 2, the climbable layer is at 1, and the structure layer is at 0. Let's finish up by selecting the climbable layer and adding a ladder to our stage. Then we can add some more solid blocks at the top of the ladder. Always make sure you switch to the right tile map before painting your tiles. And if you make a mistake, you can choose the eraser tool from the tile palette to remove those tiles. After painting the ladder on the climbable layer, we'll change back to the surface layer to add the platform above the ladder. Now that we have a simple stage set up for our player, in the next video we will begin writing the scripts that will control the player.